This is the Chapter 6, Unit 3A review. I'm going to do problems 1 through 12 of the review packet. Number 1 says name all the sixth roots of 1. So the first thing I'm going to do is I'm going to write this algebraically using notation. They're looking for this. Whenever the root index is even, so when you're taking the square root all, when it says find all, that was the kicker, I should say. When it says find all of the even roots. If you do the sixth root of 1, you're going to get 1. But all even root indexes will be accompanied by a plus or minus sign. The reason is because a sixth root means what number times itself times itself times itself times itself times itself gives you 1. Well, if you multiply 6 ones, you'll get 1. But if you multiply 6 negative ones, you'll also get positive 1. When a problem says find the principal root, that means you're not using the plus or minus sign when it's an even root. So to find the square root of 100a to the 8th, one of the ways you can do it is you can separate this into the square root of 100 times the square root of a to the 8th. The square root of 100 is 10. And the square root of a to the 8th, well, 1, 2, 3, 4, 5, 6, 7, 8 a's. Square root means pairs. Look, there are 4 pairs of a's. And you may have realized that with the variables, square root really just meant divide the exponent by 2, because 8 divided by 2 is 4. So this would be the principal root. In number 3, they want a complete list of the values of x for which the square root of 2x to the 5th is real. Well, in order for a square root to be real, the number underneath the radical must be positive. So what we do is we set the part that's under the radical greater than or equal to 0. And we solve that inequality. We've solved inequalities before. They solve just like equations. You would divide by 2, and 0 divided by 2 is 0. And then you would take the 5th root of both sides. But what's the 5th root of 0? It's 0. So in order for the square root of 2x to the 5th to be real, the x values have to be greater than or equal to 0. In problem 4, they want us to simplify this product in radical form. There are multiple ways of attacking the problem. Probably the easiest way to deal with it is to first start by multiplying these together. When you multiply the square roots together, since they're both under a square root, you can just multiply what's underneath together. 12 times 21 is 252. X to the 6th times x to the 5th is x to the 11th. Remember, that's the case where you add the exponents. And y to the 4th times y is y to the 5th. Now we're going to take the square root of each of these. Now, what happens when you want to take the square root of a variable, but the exponent is odd? Because square root is easy. You can just divide the exponent by 2, but 11 divided by 2 is 5.5. Well, think about it as the closest exponent to that number that's actually even. So if I rewrite x to the 11th as x to the 10th times x, then I can take the square root of x to the 10th. It's going to be x to the 5th. But the other x I can't take the square root of. Let's talk about the y's. Y to the 5th, well, 5 is an odd number. So how about I rewrite that as y to the 4th times y? The square root of y to the 4th is y squared, but I can't take the square root of the other y. Now let's go back and deal with the 252. Now, this is what I normally do when I am trying to simplify these. I like to write down all the pairs of numbers that multiply to give me 252, but one of the numbers needs to be a perfect square. Our perfect squares are 4, 9, 16, 25, 36, 7 times 7, 8 times 8, 9 times 9, 10 times 10. And these are the numbers we tend to use most often. So I start with Well, what's 242 divided by 4? Well, 63. But is 4 the largest perfect square that divides into 252? I don't know. So let's try 9. 252 divided by 9 is 28. I'm going to keep checking just in case. So 252 divided by 16 gave me a decimal. 252 divided by 25 gave me a decimal. 252 divided by 36 was 7. Ooh, I bet 36 is the largest perfect square that divides into 252. How do I know? 7's prime. I can't go any further. So this is the square root of 36 times 7, and the square root of 36 is 6, but you can't take the square root of 7. So now, what do you do with these three quantities? Well, you can multiply together the parts that are not under the square root sign. So 6 times x to the 5th times y squared. And then you can multiply the stuff together that is under the radical. So the square root of 7xy. And that would be the answer. The other way of dealing with the problem would be to simplify each of those radicals and then multiply them together. But if you do that, you'll have to do a second simplification. And that just makes the problem a little bit longer. In number 5, we're going to simplify the 5th root of 81x to the 6y to the 14th over 3x to the 4th y. The way I'm going to approach the problem is I'm going to start by simplifying what's under the radical before I even deal with the radical. So 81 divided by 3 is 27. X to the 6th divided by x to the 4th is x squared. Remember, that's the case where you subtract the exponents. Y to the 14th over y is y to the 13th. Now I'm going to deal with taking the 5th root. Well, if I break this down, 27 breaks down into 3 times 3 times 3. X squared is x times x, and y to the 13th is, of course, 13 y's. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. I'm running out of space here. A 5th root means look for groups of 5 of the same thing. I want you to notice that there are 2 groups of 5 y's. Nothing else is a group of 5 of the same thing. That means I cannot take anything else out. So I'm left with the 27 and the x squared. But when I take those 2 groups of y out, I'm still left with 3 y's under the radical. One of the things I want to remind you about these problems, do not forget about the root index. One of the most common mistakes students make is they simplify a problem, and then at the end of the problem, they say it's a square root instead of a 5th root. I will take points off on the test if you do that. In order to add or subtract radicals, remember that not only do the radicals have to have the same root index, but they have to have the same value under the radical. So right now I can't add these together because the cube root of 2 and the cube root of 16 are not like terms. So let's see if I can fix this. Well, I can't take the cube root of 2, but I bet I can simplify the cube root of 16. Break down 16. When I break down 16, it breaks down into 4 2's. Well, remember that a cube root means take out a group of 3. Well, I can take out a group of 2's, except that there was 1 2 I didn't circle, so it's still under the radical. What do you do with that 2 and the 5 that was originally in front of it? They get multiplied together. So now I've got 4 the cube root of 2 plus 10 the cube root of 2. Now they're like terms, and now I can add them together. And the final answer would be 14 the cube root of 2. And just as in the last problem, I remind you, remember that this was not a square root. It's a cube root. And if you write your final answer and you forget the root index, I will take off points. The other thing that I'd like you to be careful of is to not write the cube root like this. This does not say cube root. This says 3 times the square root of x, which is not the same as this. So when you write these root indexes, try to write them small and inside the little V shape so that I'm not confused. Remember, if it doesn't make sense to me, I assume you're wrong. In the stained glass window design, the side of each small square is 10 inches. What is the perimeter of the stained glass? And then it says, note that the formula for finding the perimeter is twice the length plus twice the width, where P is the perimeter. I'm actually not quite going to do it that way. So this is what we're going to do. Each square inside the stained glass window has a side length of 10. What I want you to note, though, is that these lengths right here along the edge are not the side of the square. They're the diagonal of the square. So if I take one of the triangles out of that square, the two side lengths here are both 10. What I need to find out is what's the length of the diagonal. I can actually just use the Pythagorean theorem to do that. Remember the Pythagorean theorem? A squared plus b squared is equal to c squared, where c is the hypotenuse. Let's do that. So I've got 100 plus 100 is equal to x squared. So 200 is equal to x squared. Now I'm going to take the square root of this, but I need to simplify the square root of 200, and it turns out 200 is 100 times 2. So it's 10 the square root of 2. All right, so each of the diagonals is 10 the square root of 2 units long. Well, now, how many of those diagonals lie along the edge of this stained glass window? So I counted 4 at the top, 4 at the bottom, and 2 on each side. So that's 12 in total. So the 12 diagonals are each 10 the square root of 2 units long. So it's 120 square root of 2. But that's not all the side lengths, is it? There's also these little corners. 1, 2, 3, 4, 5, 6, 7, 8. So we're going to add that to 8 times something, but times what? Well, if I look at this little corner here, this triangle, I know that the hypotenuse of that little right triangle is 10. What I don't know are these lengths. I can still find an algebraic expression for them using the Pythagorean theorem. So, leg 1 squared plus leg 2 squared is equal to the hypotenuse squared. So, by the way, when you add these, it is not x to the 4th. Really, it's not x to the 4th. I'm serious, it's not x to the 4th. The reason I mentioned that 3 times is because 50% of the students will tell me that it is x to the 4th. It is 2x squared, and that's going to equal 100. So then x squared is going to equal 50. So x must be the square root of 50. Well, 50, is 25 times 2. So that's going to be 5 the square root of 2. So each of those 8 little pieces at the corner are going to be 5 the square root of 2 units long. So when I multiply those, I get 40 the square root of 2. So the perimeter is what I get when I add these two together. And it's 160 the square root of 2 units long. From problem 8, it says explain why negative 27 to the 1/3 power is equal to negative 3, but negative 36 to the 1/2 power is not equal to negative 6. Now, let's remember what rational exponents are. Raising something to the 1/3 power is the same thing as saying what's the cube root. Remember, a cube root means 3 of the same number being multiplied together. Well, that's because this is negative 3 times negative 3 times negative 3. However, if raising to the 1/2 power is the same as square rooting, the answer can't be negative 6 because negative 6 times negative 6 is not negative 36, it's positive 36. And we can't take even roots of negative numbers when we work in the real number system. Although this is a problem that you could probably just do in your calculator, I'm going to show you how it works without a calculator. It says we want to simplify 13 to the 3/2 power times 13 to the 1/2 power. 13 to the 3/2 power is the same as the square root of 13 cubed. And 13 to the 1/2 power is the same as the square root of 13. Well, when I multiply those together, don't I now have 4 13s? Because there were 3 13s here and a 13 here. And isn't a square root asking for pairs of the same number? And I can take out 2 pairs of 13. So 13 squared is 13 times 13, which is 169. However, if you do this in your graphing calculator, I want to give you a reminder for people who use the old operating system. The old operating system is the one where when you go to raise it to a power, it just gives you the caret. You'll need to put the fractions for the exponents in parentheses, because if you don't, then the calculator will think that you are raising 13 to the 3rd power and then dividing it by 2. Instead of actually raising it to the 3/2 power, which means to take a square root. So be careful to use parentheses when in doubt. Number 10 asks you to convert x to the 2/7 power to radical form. Remember, the denominator is your root index. Make sure the little root index goes inside the little V shape of the radical. If you write it out in front like this, it is not a 7th root. That is 7 times the square root. And then you just put x squared here. There is another way of writing it. You could also write it as the 7th root of x in parentheses squared. I don't care which one you use. For number 11, the 8th root of x to the 7th power, we want to rewrite it in exponential form. The root index is always the denominator of your fractional exponent, and any other exponents that were already in the problem are your numerator. So this is the same as x to the 7/8. Problem number 12 says the expression 0.02 m to the 2/3 power is used in the study of fluids. What value best represents the value of the expression for m equal to 18 times 10 to the 4th? Remember, 18 times 10 to the 4th is your scientific notation, and the easiest way to do the problem is to just plug it in. Now, when you plug this into your calculator, it's probably just easiest to write it in your calculator like this. Remember, though, that if you have the old operating system, when you go to raise that parentheses to the 2/3 power, you'll need to put it in parentheses. If you have the new operating system, you don't have to worry about it. Either way, when you shove it in your calculator, you should get 63.8.